Yes. Hello everyone. Today I'm going to be synthesizing epichlorohydrin using starting with allyl chloride. Let's start by drawing the structure for allyl chloride. Okay. Then we're going to be using hypochlorous acid to turn the allyl chloride into 1,3-dichloropropionol or N,1,2-dichloropropionol. Okay, let's also draw the structure for hypochlorous acid using chlorine atom and OH. Okay, using the allyl chloride and hypochlorous acid, we're going to end up with this as the byproduct, which is going to be 1,3-dichloropropionol and 1,2-dichloropropionol as well. We'll also end up having this as well. Let's show that. Let's move this a little bit downward and this one a little bit upward. This is 1,2-dichloropropionol. 1,2-dichloropropionol and 1,3-dichloropropionol. And then from there on, we're going to use sodium hydroxide to convert the 1,2 and 1,3-dichloropropionol into epichlorohydrin, NaOH. And then epichlorohydrin. Now, okay. Yes. I mean, we could probably draw the structure better. Let's try that. You know what? Let's use this instead. Yes, this is the epichlorohydrin. Epichlorohydrin. Okay, let's show the mechanism that's involved throughout each step. Let's start with using the allyl chloride. Let's take a copy of it. Copy and show the mechanism to turn the allyl chloride into epichlorohydrin into 1,2 and 1,3-dichloropropionol. Okay, and we'll also get an alternative here where we'll get a primary carbocation. So let me show you guys what I mean by that. Paste. So we mean basically doing this. Let's show. basically having the negative charge on the secondary carbon as well as the positive charge on the primary carbon. And this is going to be a minor product because molecules do not like primary carbocation. Primary carbocations like to sit on tertiary alkyl halide followed by secondary. Primary carbocation isn't something that molecules like. Let's show that. But yeah, this is still going to be one of the side products, the minor product in the reaction though. Okay, following that, let's show what the next step is going to be, which is going to be the hypochlorous acid. The electron pair is going to attack the chlorine atom on the hypochlorous acid and then leave the hydroxide ion. The hydroxide molecule. And so we're going to end up with this. Let's show the answer. Copy. Come on. Chlorine is going to be added. And then we're going to have the hydroxide molecule. So the OH minus is going to attack secondary carbon. Let's show how this is going to work. And so this will happen. Let's show. The electron pairs here will attack the secondary carbocation here. So we're going to end up with this as the byproduct. Copy and paste. Okay. Now for the other molecule, I'll show for how the mechanism is actually going to work out, which is pretty similar. Let's move this a little bit downward. Copy. And of course, the electron pairs here as well is going to attack the chlorine atom, which is going to remove the hydroxide molecule. And so we're going to end up with this as the byproduct. Show the answer. Primary carbocation would be looking like this. And of course, we would have the OH minus as well here. And the electron pairs on the OH minus would attack the primary carbocation. So like this. Okay, and we would end up with this as the byproduct. Let's take a copy of it, which is 1,2-dichloropropionol. Right. Okay, now following that, what we're going to do to change both of these molecules into epichlorohydrin is to use sodium hydroxide to remove the hydrogen atom on the oxygen, which is then going, the oxygen itself is going to remove one of the chlorine atom and form O-ring. Epichlorohydrin is going to form the epichlorohydrin. Okay, let's show that. This, copy, paste. And then NaOH, sodium hydroxide. Na plus, and then OH minus. Move this down a little bit. And so the OH minus is going to remove the hydrogen. And break the covalent bond here, leaving us with, let's show what the byproduct is going to look like. Leaving us with this as, right, let's remove the hydrogen. With this as the byproduct. And let's also show the electron pairs as on the oxygen atom here, so that we can show how the oxygen atom is going to remove the chlorine, one of the chlorine atom, one of the chlorine. And let's show that. Let's just try to use this. Okay. And so the chlorine is going to be removed. So this is going to form orang, and it's going to form the epichlorohydrin. Let's just take a copy of this. And it's going to be pretty much the exact same thing for the other formula as well. I mean, we've pretty much run out of space. I'll open a new page, and I'm going to show you what the other mechanism is going to look like. Pretty much just the exact same thing. But let's show it as well. Let's take a copy of this, 1,2-dichloropropionol, and show what we're going to end up with. Let's move this. Let's see. Let's just move it that way so we can show how the mechanism is going to work. Count NaOH again. Let's just go and take a copy of NaOH here. Copy and paste. And let's show what we're going to end up with. copy, paste. We're going to end up with this. Show the electron on the oxygen atom, as well as the negative charge. And so, of course, this oxygen atom is going to remove this chlorine and form the epichlorohydrin. Okay, and the chlorine atom is going to be removed. All right, maybe this isn't the right way for you guys to to see the mechanism well, but you know what? So basically, the electron pair here is going to attack the carbon, which is then going to remove the chlorine atom. I'm sure you guys understand. And so we're going to then form the epichlorohydrin. Once again, let's just make use of this to form the final byproduct. Yes, so this is the final product for the epichlorohydrin. Thank you for watching.